Intuitively, I want to take a look at how you can communicate between processes using just signals. So we looked at how to send signals, we looked at how to handle the signals, but we only worked with signals that already did something special, right? They were either terminating the process or stopping the process or continuing it. This time I'm going to take a look at a signal that doesn't do anything by default. So to start off, there's going to be a simple problem that we want to implement. What I want is just a simple question to be asked by the program, and the user is going to have to answer it. And if they answer it, that's great. If they don't answer it, that's also great. But if it takes longer than like 5 seconds to answer that question, I just want that user to receive a hint. How can we do that using two processes? First, we're going to create two processes. I'm going to use a fork, so of course fork, and also do check your process ID. If it's -1, then it's going to return an error code. Simple enough. If we are in the child process, then we're going to do some hinting on that side, but I'm going to leave the logic for that for later. First, let's create that question. So first I'm going to ask here a question. Let's say, what is the result of, I don't know, let's say 3 times 5. Okay, and I'm simply going to scanf this variable into this variable. So scanf the address of x, actually %t here, like that. And well, if x is 15, then let's print out right, and otherwise let's print out wrong. And that's all the program is basically going to do. Our parent, this is the parent process. I'm gonna actually say here parent process. But I also want that hinting part. So I want the process to sort of wait 5 seconds and then send me a hint. How can we do that? Well, we can't really do it here because we're already waiting for this scanf, right? Where the parent process, what it executes, says, okay, I'm going to print out this statement. It's going to print this out on the screen, and then it's going to wait for our input. It cannot also wait 5 seconds, right? So we're going to have our child process do the waiting for us. So what we can do is just simply say sleep of 5. There should be 5 seconds exactly, and after it sleeps 5 seconds, what I want it to do is to send the signal to the parent. Send a signal to the parent saying that, oh, you should print out a hint. Well, if 5 seconds have elapsed here, that means that we should send a signal to our parent here. So I'm going to say, I'm going to use the kill function. The kill function takes in the process ID. So we know we are in the child process, right? We want to send a signal to the parent process. We can get the parent process ID by just saying get PPID. That's going to be the parent process ID, which is this guy. And the second parameter is, of course, the signal that we want to send. Now the question becomes which signal you should send, and here we have a lot of signals, right? But they all really do something. This guy sort of child stopped or terminated. It does floating point exception. We don't want to do any of this. This says it's an illegal instruction or whatnot. But if you look down, there are 2 signals that can be used for user-defined operations. So if you're to send these signals without handling them properly, they're just going to terminate the process. But we can actually override these, and these are meant to be used only for user-defined operations. Here, these are never used inside the Linux kernel anywhere for specific, for generic process operations, right? Only in applications specifically developed to use these signals, you're going to see them used. So in this case, we can actually make use of these. These are sort of blank slates, and we can send, for example, we can send the SIG USR1 signal to our parent. So in here we can say SIG USR1, and that's about it really. It's gonna send this SIG USR1 to the parent process, but well, the parent process doesn't do anything. It just, remember, there's a default behavior for all the signals, and in this case, for SIG USR1, what it's going to do is just terminate the parent process, and that's it. So this is not okay. We have to also handle this process using that SIG action that we have used before. So to add the handle, we simply declare here another struct. So it's a struct of type SIGAction. We'll call it SA. And again, we need to have inside this SA a few things set up. First is the SA flag that has to be SA restart. That's just because we're using scanf and we want to basically restart scanf once it's finished its execution. If you don't use scanf when you're actually handling the signal, then that's all fine. You don't need to set up this flag. And to make sure that all the members of the struct have been initialized to 0, for example, I'm going to set it so that it does just that. So next up is to set up the handlers. I'm going to have here SA_handler, and this should be a pointer to our function that we're going to have to create. So this is, let's call it handle_SIGUSR1. Okay, so that's going to be our function's name, which we're going to define up top here. So I'm going to say void that, and that's the signal. And lastly, what we have to do is actually bind this SIGUSR1 signal to our handler. So I'm going to say SIGAction, now the function SIGAction, that takes in the signal that we want to bind, which is SIGUSR1. We want a reference to our S8 or SIGAction struct, and then last one is going to be null because we don't make use of it, the old SIGAction. And that should have bound this, whenever we send this, it should call this handle SIGUSR1 function now. Now what do we do in here? Simply we print out a hint for the user to read. So you can say here, remember that multiplication is a repetitive addition, and a \n. So that, and I think we can actually note it as a hint here. Let's say hint, come on, just like that. And now that this handle is actually handling SIGUSR1 in a special way, it's no longer gonna just terminate the process. And of course, I think I forgot is to add a wait here at the end of the parent process so that it waits for our child process to finish. Okay, so now if we try to launch this by first building the project and then launching it through the terminal, again, I don't want to launch it through the IDE because I have it set up that it will launch it with GDB and it's gonna cause issues. So here we can just say /main after compiling it, and you'll notice it asks me the question, so I can answer it, 15, and then hit enter. And you'll notice that I still get the message on the screen, even though I did say 15 here and it did say that it was right. It did give me the hint and then it finished executing. So how can I stop it from doing that? Well, a quick fix would be to first move the X variable to be global, like this, initialize it with some value. Now we have it already initialized with 0 because it is global, but I'm just gonna make sure and be specific about it. And then we'll check if X is actually 0. If it is, then we know that it didn't actually change, so we can print out this message on the screen. Otherwise, we just receive the signal and we don't do anything with it. So this way we should be able to not print out this message again. And also because I noticed that here, see, here's our message with the right, and then right after is our hint. I would also like to add a new line right after, or right before the message, so we know it's on a new line on its own. Now if I try to first compile it and run this, I'm going to clear and then /main, say 15, and then it should actually print out right, and it's no longer going to print out anything else on the screen. But of course, if we clear it again and launch it and we wait 5 seconds, it should print out on the screen saying that, well, we haven't read anything, and sure enough, we get the message. And then we can say 15 and it's going to say right. Okay, so now we know that this works. As you can see, this is done by waiting in the child process. It's sending this SIGUSR1, and this SIGUSR1 is handled in the parent process like so. And this function is being called and it's printing out on the screen. So this is how you can communicate between processes using just signals. But as you can see, I didn't send any data from the child process to the parent process, because with signals you cannot send any data. They are just signals, they are just sort of a notification with no information, just a number. So because of that, it's not easy to communicate just with signals. And another important thing that I left out is that these handles that are handling signals, they are really, they should be very atomic, in the sense that they shouldn't really modify global variables, they shouldn't really read or write to files, or even print out on the screen something. Remember, you can actually have this function executed in between function calls, and really anything could happen there. So it is recommended that you actually pay close attention whenever you're using these handles. In our case, it's fine because we're just using SIG-USR1 and it's our own little project here. We're just trying it out, but for the most part, they have to be atomic operations. Okay, that's about it for this video. I hope you got something out of it. If you do have any questions, again, down in the comments below or on our Discord server. You can join and ask in there. Thanks so much for watching. Take care. Bye.